Alright, welcome to the first technical video of the channel. We're going to start off on CAD, which is computer-aided design, or computer-aided drafting. I've kind of heard it both ways. They kind of go hand in hand, and when you refer to design, typically that is taking an idea and making it a 2D or 3D part. Generally it's 3D. I don't really see 2D used too often. I've used 2D to analyze linkages and how they kind of might bind, or the geometry on there. But generally design is done in 3D. And in 3D you can really communicate how a part takes up space and volume. You can get mass and identify center of gravity, tolerances. You're going to specify materials, coatings, part names and numbers, and anything related to the part. And once the part is designed, you can then take a number of parts and put them into an assembly and figure out how they interact, whether they're bolted or welded or threaded together, however that works. That'll create an assembly or a kit, kind of one and the same, depends on your vernacular. And then once you have parts and once you have assemblies, you'll create drawings for both, so you can communicate it to internal or external customers like machine shops and production lines exactly what's expected of a part or an assembly. So you'll get exactly what you need the first time around. That's like a contract for a technical contract. So there's a lot of uses for CAD. It's a tool for design, it's a tool for procurement, and a lot of other departments within sort of a manufacturing setting, or for hobbyists, it's generally just to see what does a part look like and how they occupy space, to kind of give you spatial awareness and how that's going to look. It can also communicate to customers what their final product is going to look like. Some people are very visual, and it's useful for them to see that. Now, in terms of CAD package options, you really can't go wrong. Some of them are maybe a little bit better than others for certain processes, but at the end of the day, they generally all have the same functionality. And I'm going to say the word generally quite a lot, because there are so many different uses and there are so many different ways to even do the same thing that it's kind of hard to talk about all scenarios. That's not really possible. But the big CAD packages are going to be SolidWorks, Inventor, CATIA, NX, Creo, Infusion. I think there's some others out there, but those are kind of the most common I know about, I've had experience with, or just anything like that. In my opinion, SolidWorks is the best all around. I think it's the most powerful. It also happens to be the most expensive, or one of the most expensive CAD packages out there. It's what I use on a daily basis when I'm at work in the aerospace field. Then you have Inventor, which I think, in my opinion, comes second in this lineup in terms of what I'd prefer. Again, these are all personal preferences. The user interface, I don't think it has all the functionality that SolidWorks has, but the user interface is my favorite so far. I think it's just laid out really well. I think there's some simple tools to kind of keep you organized and do some things a little bit easier than some of the other packages. And then there's CATIA, which has a really phenomenal sheet metal environment, and we'll talk more about that later on. It's kind of a specialized environment of design. Everything else was not that great. Didn't really enjoy using it beyond that. Sheet metal environment, like I said, was phenomenal, and that may be because of the effort of the company that I work for in developing that. But then there's NX from Siemens, which I have no experience in. I don't know anything about it. I've never even seen the user interface. I just know it exists. There's also Creo. I am not a fan of Creo. I did not have a good experience. I worked in it for a couple months, and it was just extremely buggy and latent, and my preference would be to not use Creo ever again. And the last on that list is the one that I'm showing here, which is Fusion, and that's the one I'm going to be using. I think it's what people have access to the most. It's very powerful, especially for the price that Autodesk is listing it at. And if you're using it just for hobbyist use, I think it's actually free still. It was for me for a while before I have a paid license. Um, and if you have Inventor, it should look very familiar to you. A lot of the icons are, and the way it's laid out is very similar. So if you're using that, you might follow along pretty well in here. So we're going to be using Fusion. Now, when you're in Fusion, we're going to talk about configuration management and saving parts and data control, document control, sorry, a little bit more in later videos. So how this is set up and the workflow of what it takes to create a part and where it's all going to happen. We'll show that a little bit later, but for now, just when you're creating an initial part, you're really going to have three options for almost all CAD packages. Hybrid design is something, as far as I know, is unique to Fusion, and I don't really have a full understanding of what that is just yet. Probably won't ever use it. Electronic design, I don't really have a background as an electrical engineer or designing PCBs. I know that is a thing for a lot of people. It's becoming increasingly easier to access, so I understand why they have that environment here. And then libraries, this one in particular showing an electronics library, but you'll have a library for very common parts like screws and pins and things like that that you'll buy from McMaster or Fastenal or anything like that. That's usually just stocked items. It's really convenient to have a library. I don't have one set up in Fusion just yet, but that's there. I wouldn't really, if I was setting this up from scratch, I wouldn't really have these three at this level. It would be something I would access at the assembly level and input as I needed for the library parts. But in general, you're going to be using, or the general use is going to be part design, assembly design, and then drawing, usually in that order. Now we're going to start off with part design and cover sketching and just how parts are created, and we'll work our way to assemblies and finally to drawings, which takes as much technical effort, in my opinion, as it does to create parts and assemblies, because if you're not communicating what you want well, then you're not going to get it, no matter how well it's designed. Now when you're in the part, you can also switch to the sheet metal environment. We're going to stick in just the part for now, and I think you can even do that up here with the toolbar that you use. But once you select the template, you're just going to hit Create New, and you're going to be in the design environment. Now there's a couple others that are available. The way you access this is different in other CAD packages, but for the most part, you have access to them in other CAD packages. Generative design, I've never seen this anywhere else. This is where if you have a part or maybe some known geometry that you need, and you know the loading, like what's shown here, you probably have to lay out this feature up here, and you know your mounting points down here, and you would input your known forces, whether they're thermal or mechanical or whatever that might be, and Fusion is going to use math and likely some FEA behind it of what's the best structure you can develop to create this, given all the constraints. That's generative design, and I know some car companies are using that now. It's kind of difficult to make, and we'll talk about that when we get into manufacturability. 3D printing really would be the only way I could think of making something like this. If you gave it to a machinist, they would probably throw it at you after they've made it. You get into render, which is actually useful to show customers, or even just to see what your product is going to look like. When it's made, it's just a realistic way of showing assembly and parts. Animations, usually to show customers, maybe to see for yourself how things are going to work together. So think of like animating how a bike would rotate if you rotated the pedal assembly, and seeing all the sprockets and things mesh. I never really spent too much time with it, but it is kind of useful to show others, especially if your end users are not technical and they just like to see how it's all going together. Simulations, this is to simulate thermal and mechanical stresses from different inputs and seeing the life expectancy and where it may or may not fail. Manufacture is going to be setting up tool paths and basically how to make parts whether that's injection molding or 3D printing. Machining is probably the most common in the manufacturer the manufacturer environment here. And there's drawings, which we're gonna make drawings at some point, and finally the electronics. Now we're going to stay in the design for the part level, and when you're designing parts, you're really going to be in one of three categories. You're going to be in the solid category, which is just going to be the general plates and brackets and those kind of basics, even tubes and something you do like exhausts or manifolds or anything like that. It's going to be done generally in solids. If you get into something more complex, you might get into surface, but surface modeling is generally like, think of like a Windex bottle, like a spray bottle, like how you would design something like that. Generally it's not parametric, and parametric means that your models are built using dimensions. They're not just eyeballed, and I'll kind of show what that means with the sketch in a minute. You have your surface modeling. Mesh probably won't be in here too much outside of your FEA. Sometimes maybe you're modifying your meshes for STLs for 3D printing. I don't use 3D printing too much, but the environment, or this toolbar is here for mesh. And then probably solid and sheet metal are the two most common that I would use. And anyone in sort of a mechanical engineering type role or manufacturing type role would be in. This is creating sheet metal parts, so all the different bends and features you're going to have there. Plastic is something I've never seen before. I think this is actually new in Fusion. Probably wouldn't use it. It takes some specialty tooling, I'd imagine, to make compliant mechanisms and some of the features that they're going to have up here. But it's useful, or it may be useful. It's there for those that need it. The managed toolbar is going to be for more professional settings. So this is how documents would be controlled in terms of revision, how they're released and viewed to other key members and things like that, usually through PDM or PLM. I know Autodesk has something called Vault. I've used it in the past. Very convenient. And I think this is the plugin for that, and we'll kind of show that as we go along. And utilities, kind of just a miscellaneous collection of different tools. Inspection, so how you'd measure parts, and I don't really use too many of these. Section analysis is actually useful, especially in complicated like hollow parts or in assemblies. And then center of mass, if you want to show kind of where the mass would act as a point on a part or an assembly. You can configure your materials here. So if, let's say you made a part out of acrylic or some other metal, plastic, wood, whatever it is that you have. So 5052 H32 is a super common aluminum alloy. These are all baked in from Autodesk, and you can add them. You can also, I don't think you can modify these are locked, but if you wanted to recreate them and maybe put in some different parameters, you could. It'll give you the settings they have for the appearance, and then you can go into physical and set the thermal properties, so thermal conductivity, all the different mechanical properties, and just general strength, so that if you're simulating, you have very accurate data and you know how it's actually going to behave. Now, back to the solid environment. Your toolbar, or your tools that you're going to use, are mostly going to be in this area up here, and you can really make this your own. You have some other features up here. So configure is if you have versions of a part. Let's say you have a bracket with 5 holes and you want to keep that same part number and maybe add a 6th hole for certain parts. It can get very tricky with how you manage that. I recommend, if you do that, to put some thought into it, because it can kind of make things really complicated, but it is there. I use it at the assembly level mostly, not at the part level, but it is a possibility. I use construction geometry a lot, both in sketches and at the feature level. I find it really useful. I don't think too many other people use it. I also think it can be easily misused, and I'll show what that looks like later on, but this is just ways of creating different planes, points, and axes to help create the part a little more simple, or make it a little more simple to create the part. And then you have your inspect tools again here. They just have it listed twice, so here and in the utilities. Insert, this is a little nuanced, not really too much of a use for this for most of the applications I could think of. You can add parts from this part to an assembly using this tool. Don't really use that very often. Something that Autodesk does really well though is their selection tools, so you can select whether or not it's a point, a line, or a face, a body, anything like that. Really interesting. I think they do it better than anybody else that I've seen. I really appreciate this actually. Now, so you have all your tools up here. No matter what CAD package you're using, you probably have some toolbars like this, just to show, you know, what you're actually going to be viewing. If you're going to filter out points, your display settings, your visual style. So if you want edges shown, you want hidden edges there, you want things to be realistic or kind of more cartoonish, the lighting, all those kinds of things. You can free orbit, pan, zoom. That's kind of universal to pretty much any CAD package you're using. And then the other thing, you're usually going to have a coordinate axis. It has it up here. Actually, it's really convenient to navigate like this. I definitely appreciate this from Autodesk and how they did this. So you have your different views. This is going to be one of your isometric views. And then off to the side here, it's a little different actually in Fusion than any of the other CAD packages I can think of. They have their model tree split up between the left side here, and as you develop the part, it will kind of, on the bottom, it'll grow here as like a timeline to show you how you've progressed through. I prefer it all to be in the model tree, and we'll see what that looks like maybe at a later date, just kind of how it's all laid out here. But what they do have up here, and one of the first things you want to touch on when you're designing, is you want to change or make sure that your units are what you expect them to be. This is completely personal preference. I think you can be wiser with certain decisions, but not wrong. And even if you pick one or the other, you know, say you took a measurement in inches, but you're using millimeters, you can generally input different units and it'll make the conversion for you. But just know that that's there. If you design in the wrong one, it can kind of be a pain and throw things off for you, so just be aware of that. Now you can create views in here, and they have some pre-selected ones. So you got your top, front, right, which are generally your three main views you're going to use. It defines another one as home, which we'll see what that looks like shortly. And then probably the most useful part of this tree here is going to be your origin, which is the point, like the home, the center point of your design. This is defined as 0 for your X, 0 for your Y, and 0 for your Z. So that's going to develop your triax for your three orthogonal axes. So you're going to have your X, your Y, and your Z. You can call them whatever you want. Sometimes they're IJK, at least in school they were, when you're talking about theory and vectors and all of that. But X, Y, and Z just puts it on a coordinate axis. And from that you have your XY, which is your bottom axis here in this case. Then you have your XZ, which is this axis, and then you have your YZ, which is your third orthogonal axis. So that's going to be your basic layout here. Now, if you're in Fusion and there are certain features that you want or think you're going to use, or you find out that you use as you're learning this more, you can go through and remove tools up here and add ones that are down here, so it's just a little easier for you to find. Fusion also has these drag functions. I turn them off because it just annoys me, but if you right click and kind of drag, you can show different tools that you can use. Makes things a little quicker, a little more efficient. I generally use SolidWorks, so I'm used to that most of the day, and I just get mixed up when I switch back to Fusion, so I kind of turn it off. I use a different keybind for all of that. Now before we close out on this video, I will show something useful that I think will really help people that are using Fusion, because you have to hold different keys to rotate and pan the model. So generally I use in the right hand, I use a CAD mouse. There's nothing special about this mouse, I just think it's comfortable, and there's quite a bit of buttons you can configure on this. It's just, I like it a lot. And then you can use in your left hand something called a space mouse. So think of it as like a joystick, so you can really pan around. It works on all three axes, so you can zoom and then rotate you can control, basically orbit around a part. I use this at work, and I have a personal one here. I've purchased these. They're not given to me or anything like that, but this makes life so much easier when you're using CAD. Certain CAD packages like SolidWorks, I can keybind my mouse where I don't actually need this, and sometimes I find myself using it, sometimes I don't, but in Fusion and Inventor, this is just so much more convenient. So if you have the opportunity and you're curious, I highly recommend going with something like this. I think I've seen one other person copy this, or one other company copy it to do something different, but I just think CAD Mouse did a really great job with it. So really recommend this. The next video we're going to go into sketches a little bit more, or we're going to go into sketches, and it'll probably be a multi-part video, just because I think that's where you can make or break the design process there. So, and we'll work our way into assemblies and drawings and just a complete overview of what it takes to design a part. So, thanks for watching, and catch you in the next one.